Well, here we are with my power supply repair, video number 2. So I got all the caps that I needed. We're going to recap this power supply and hopefully improve its performance because it was pretty bad. So at a 1 amp load, this power supply had about 10 millivolts of ripple. At 2 amps, it went up to 30 millivolts. At 3 amps, we started getting around 175 millivolts. And then when we went to 5 amps, which is supposed to be this power supply's full output, the noise and ripple jumped to 2.25 volts. And so we're going to replace these caps, and we're going to replace this one here, this bypass cap here, and the 2 primary filter caps, but we're going to replace them both with 4700 microfarad caps, so we'll get a little more capacitance in there, so it should improve the performance of the power supply. So with that, I will open her up and start installing. Well, here's step 1. We got the caps out. Yeah, that one there. I was going to test that one to see what value it shrunk to, but yeah, it definitely leaked. So we'll have to clean up the board a little bit. And this one here, we'll test this one, and we'll test these other two just to see if they were still in tolerance or not. But yeah, that cap definitely blew out the electrolyte there. So, but other than that, I mean, the board's in pretty decent shape. You can see where the where this stuff is here. But I've installed the other 2 smaller caps, so I'm getting ready to install the larger filter caps. So not too bad, pretty easy. So not bad. All right, onward. Alrighty, everything's all put back together. Filter caps are in place. Everything is ready to go. So finish putting the case on and get all the appropriate equipment turned on and set up, and I'll give this thing a load test and just see how much better it does. Hopefully, it should. It's got to be an improvement over what it was. So let's get to it. Alright, now that this power supply has been on for about 30 minutes, I'm showing about 900 some odd microvolts, 1 millivolt, maybe a little bit over of noise and ripple. Our peak to peak is about 14, 15 volts or so, 9 volts occasionally. But we're showing about the same here, about 1 microvolt or about 1,000 microvolts or 1 millivolt of noise and ripple, the occasional blip there. Right now we're just resting at around 13.85 volts. I haven't put a load on the supply yet, but we'll load this supply down and just see how well it does here. So we'll be getting to it. Alright, with 1 amp load, we're up to about almost 1.5 millivolts. I have the scope set for 1 volt per division, so there's no visible ripple there. And the voltage is hanging around 13.8 volts, so we're doing good there. So now let's up the current limit to 2 amps. So we'll set the current for 2 amps. Voltage dropped down to 13.74. Still no visible ripple at 1 volt per division. And let's see where we're at now on this. We're about 2 millivolts of noise and ripple. So we'll just keep going. Let's see, what did we have last time? At 2 amps we had 30 millivolts. So we've got increased this by a factor of 10. Better performance. Because at 1 amp we had 10 millivolts before. So yeah, we're looking really, really, really good so far. So I'll bring the range up, and now let's go to 3 amp draw. Current for 3 amps. Now down to 13.67 volts or so. And we got something starting to show up, but it's just basically just pulses. And now we're up to, now we're up to about 18, or no, about, oh, what am I looking at here? Okay, we're up to about 60, or no, 6 millivolts, almost 6 millivolts now. So we're looking good there. All we got is just little spikes there, about jumping all over the place. 200, 400 millivolt peaks. Okay, let's get that back down there. Now let's go to, what do we got now? Let's go to 5 amps. So we'll go to 5 amps. Okay, now we're really dropping the voltage there. And yes, we're at, oh yeah, we're at a good almost 300 millivolts ripple. But we had a lot more last time. We had 2.5 or 2.25 volts. All right, let's see here. We need to increase. Yeah, so we're 5 volts peak to peak there. So yeah, that's doing okay so far. So let's shut that load off, and I'll switch over to the other meter, and we'll measure load regulation. All right, with a 1 amp load, we're showing a load regulation of 0.4%. So now let's go up to 2 amps. We have a load regulation of 0.8%. Pretty good. Let's go to 3 amps. We have a load regulation of 1.4%. And let's go to 4 amps. We have a load regulation of 3.2%, so not quite what it says in the book, not quite in the manual. But let's see, at 5 amps, I believe we had 20% last time. Yeah, we're still doing the same. It doesn't like that too much, so I'll just turn that off. Well, anyway, it's a vast improvement over what it was. So I would say that's perfectly good for 3 amp draw, no problem. 5 amps, yeah, it could do it for a little while, but it's probably going to overheat and shut off. But there you go. Not bad. Simple little project that just about anyone can do. It's, be surprised how well these things actually work when they got brand new caps in them. With that, I want to test these other caps that I took out, and just to see how bad they really were. Okay, the first cap here is this 10 microfarad that we pulled out. Yeah, it's bad. It won't even test it. Alright, next up, a 100 microfarad capacitor. Oh yeah, way bad. Well, how do you like that? 87 ohms ESR, yeah, bad capacitor, not even close. And lastly, the 2200 microfarad capacitor, since the 4700 was toast, and we're not even going to test that one because it's missing, threw it in the garbage because one of the legs fell off. So let's test this one, see what we come up with. Well, it says 2206 microfarads, but it's probably usable. I mean, the ESR is 0.21 ohms, but V loss is 3.3%. So yeah, I'm going to toss that one too. I'm not even going to bother keeping it. It's not going to be used for anything. So let's go on to the next thing. Well, now that the power supply has been warmed up and loaded down, I'm going to plot or send this to the plotter. It's something really cool to do. So right now it's warmed up. Well, the power supply is warmed up, so it's the noise level has risen just a little bit. It's a little over a millivolt. So I'll put a sheet of paper in the plotter and we'll plot this bad boy off on here on the scope. All right, ready to go. So come over here to the plotter. I'll lift this up so we can see what's going on. And let's see here. Here we go. All right. Done. Hard copy, ready to go. Well, anyway, I think this is it for now. This was kind of an interesting experiment. But anyhow, yeah, as I said, you know, these old supplies, I mean, this was just a real simple repair job. I mean, it's kind of fun to mess around with this stuff and get these old power supplies working again like they should. But it's not quite meeting the specs that were listed in the service manual. But I would imagine that's probably for the little stiffer built power supplies. I would imagine this thing would have no problem at all with a 2.5 amps continuous load, going to 5 amps occasionally. So that's it for now. So we'll catch you guys later. Thanks for watching.